Hello, ladies and gentlemen. So what we're going to do is we're going to build one of those fancy dancy graphs that we saw in class today. So let's see here. I'm in Desmos, and look, it's desmos.com, and I'm going to first put in a function. I'm going to call it f of x, and let's start off with x squared. So x, the caret symbol to the 2, and we get a very nice parabola there. And I can also use this keyboard down below to put in things that I need as well. So once I've done that, I'm going to hit return, I think, and it sets up a secondary form here. So what I'm thinking about this is maybe I want to have a slider on this, so a point that'll slide along this curve. So I'm just going to play here. I think this is what I do. I'm going to bring in a parameter c, and then I'm going to let the range value be f of c, and finish that off. So I invented this. This is a parameter. This is a parameter of c. So c is going to go in, and that'll be our x value, and this will be our range value. So we'll get to add a slider, and it comes up with the slider between negative 10 and 10 for now. So it's going to go out to here, and it's going to go out to here. Now, if it's going to be squared, it's going to go up to 100. So that's way off our graph. So I think what I'll do here is change this to negative 5. And I think I'll change this one to 5. And the step we can give it, I don't know, let's give it a 0.1 step and see what that looks like. And so we can hit equals. And we now have that point moving along that curve. So those are different points on that curve. If I wanted to, I could increase this domain a little bit, maybe take it out to negative 7, maybe take this up to 7, and go. Let's see what our slider looks like now. Okay, that's kind of impressive. Okay, so that was my slider. I'm going to come down here and open up 4. So I think what I'd like to do now is create the derivative. So I'm going to create a new curve. We're going to call it g of x, and it's going to be equal to the derivative of our old function f of x. Okay, let's see how that works. So yeah, that's going to be the derivative. It's there. And I would like to create a slider along that. Okay, that's my derivative. I'm going to hold on to that for a second. I'd like to create the slope of the tangent line. Now, the slope of the tangent line, everywhere that this blue dot is crossing, will come about using y equals mx plus b. No, that was a complete lie. It'll come about using slope equals delta y over delta x. So my slope in this case is going to be g of c. That's going to be the slope. And I'm going to multiply that by, I wonder if I could do it this way. I wonder if I could do y minus f of c. And all of that would be divided by x minus c. I wonder if that'll work. I don't know. No, it didn't like it. So let's bring this over here. X minus c here. There we go. So it likes this format better. Meant the same thing. We'll change this to y comma f of c. No, that's minus, sorry. And I think what I've created is the tangent line. Okay, I'm going to turn this off for a second. I'm going to turn that off by pressing on it. So it's now off. So this is actually slope equals delta y over delta x, where the delta x was brought up. We talked about that in class today. And now, if I want to show, so this is the slope of the tangent line. let's see. If I want to show all the slopes of the tangent, we're going to create another point, and that point would be given by c, again that's that parametric value, and g of c, which is the derivative of my first function, and you'd see that point traveling along. Let's see if I can get rid of this. There it is. And if I want to put in the graph of the tangent, or sorry, the graph of the derivative, this is it here. So this quadratic has a derivative function that is this linear function here. And interestingly enough, I can tell, whoa, ooh, that was cool. I can tell you that the derivative of this is 2x. So this line here is actually going to have a slope of 2. So if I go over 1, I'm going to go up 2. Let's see what this point is. Let's try to get it to go on. So 10, 20. So rise is 20, run is 10, so that's 2. So that works out. So now with this, you can have some fun. You can start changing some things. Maybe we want to move this up 4. I'm not sure why you'd want to, but you could. Let's say you wanted to change this to have a vertical compression. So there you go. We could have some more fun with this by taking this function and changing it to maybe a cubic. Maybe we can bring that out a little bit, and maybe there we go. Starting to make it look a little bit different. Now we've got something interesting. Maybe that was a bit big. There we go. Hey, now we got something. Let's turn off this. Let's turn this off. Let's turn this off, and let's just see what we have here. We have a function, and we've got our point running along the function. Maybe I want to change this now to come out to maybe -15. And we'll have the other one go to 7. That seems to be pretty good. Let's run it and see what happens. That's kind of neat. Ooh, let's bring this down. Maybe take that down to 3. Maybe slow it down a little bit. A little bit more than 3. That's going to come up. Okay. Now, let's bring in the slope of let's bring in the tangent line. So that's the tangent line everywhere across that curve. Let's look at the slope of the tangent for every x value. So try to reconcile that in what you're seeing. And let's actually bring in the curve of the derivative curve. And try to sit and look at that for a while and reconcile all the different moving pieces and what they mean. Okay guys, hope this was fun. Play around with it, see what you come up with.